mode.
Good afternoon and welcome to Idioms for Building Distributed Fault-Tolerant Applications with Elixir with José Valim. Just a quick note about eSynergy Solutions before I hand over to Jose. eSynergy specialise in open source and cloud resourcing. If you're looking for a new role or to build out your team, please get in touch after the webinar. Now, moving on to some housekeeping. If you've got any questions for Jose, please fire them over via the question box throughout, and Jose will answer them at the end of his talk. We are recording this session, and the slides and recordings will be made available and sent to you tomorrow by email, along with my contact details. Now, I'm going to pass over to Jose to begin the talk.
Thank you for the webinar. Today I want to talk about Elixir. And Elixir, as we'll see, is a relatively new programming language. And the goal of this talk is not to talk about like some particular features of Elixir or how to use Elixir in general, but it's more to explain how Elixir, and a lot of, as we'll see, a lot of it is because of the virtual machine and platform Elixir runs on, the Erlang virtual machine. How Elixir and the Erlang virtual machine really changes the way we write software, right? So the title of the talk is Idioms for Building Distributed and Fault-Tolerant Applications. And what I want you to come out with at the end of this talk are exactly those idioms, a set of new words, a new way of thinking and seeing things. So let's get started. So about history, because a lot of people ask, why create a new programming language? Don't we have enough? Okay, and my personal history that led me to Elixir and to create Elixir was quite some time ago. I was on the Rails core team, and Rails is a web framework. And in 2008, 2009, we released a new version of Rails, which was at the time Rails 2.2. And one of the main features in this release was that Rails 2.2 is thread safe. Okay, so what was happening here is that the Rails core team knew at the time that concurrency was becoming more and more important, because at the time, again, 2008, we were already starting to have machines with more and more cores, right? So, for example, today, even our phones, they already have 2 cores. Some phones have 4 cores, okay? So the whole idea of releasing a Rails version that is thread safe is so we can get our web server, right, run it in production, and it's going to use all of the cores on that machine, okay? So it was 2008, so we had this idea, our CPUs, our machines are not getting any faster anymore. So we're starting to have machines with more and more cores, and we want to be able to leverage those cores in production. So that was the work that happened here. But there is one very interesting thing, okay? So when we think about the word thread safety. So what is thread safety? In a lot of programming languages, right, the main way we can get concurrency, so for example, if we have multiple cores, the main way that we can make our software use all those cores is by using threads. And thread safety means that if you run your software with threads, your software is going to behave correctly, right? Your software is not going to crash or bugs will show up and so on, which from one's perspective, right, it's really weird, because we kind of expect all the software to run correctly. Thread safety doesn't talk about effectiveness or efficiency, right? It just says that your code is not going to break, which is a very weak guarantee, right? That's kind of the minimum we expect, is that the code is not going to break. So so we had a Rails 2.2, and it's kind of showing, we are worried about concurrency, running more and more cores. And then later, I joined the Rails core team, and I've kind of realized that this thread safety in Rails, it's actually quite hard because, and it's not Rails' fault, but mostly the fact that a lot of the programming languages we use today, okay, they do not have the proper tools for us to think about concurrency and for us to write concurrent software. So this was me back in 2010, right? I was trying to maintain Rails, trying to make it faster using threads. So when we start to have more and more cores like we have today, it's very easy to deploy to a machine with 24 cores. I wanted to do all those cores efficiently. And the whole process, the whole experience was very frustrating because the tools were not good. So I thought, well, if concurrency is becoming important, more and more important, and the tools here are not good, someone somewhere may have solved this problem efficiently, okay, or correctly, or in a more productive way. So I started to look for other alternatives. And I started to look at other languages, at other platforms, and eventually I found this thing called functional programming, okay? And functional programming, so Elixir is a functional programming language, and a lot of the ideas in functional programming resonated very strongly with me, okay? For example, one of the things that we have in functional programming is that we want the state to be explicit. That's one of the ideas that we have spread out through the many functional languages. And the reason why this is important is because, for example, if you take an object-oriented language, the whole idea of the object is to encapsulate the state. So you have all those objects that is encapsulating the state. But the issue is, when we are talking about concurrency, a lot of the concurrency bugs, they come from changing the state. And then if the state is hidden inside objects, it's really hard to reason about it, okay? The other thing is that we have in functional programming is, what if instead of changing the state, what if we transform? So one example is, if you have a list in Elixir, we cannot mutate the list and remove an element. Every time you remove an element from the list, you get a new list without that element. So if we are transforming instead of changing things in place, our software does not only become easier to understand because things are no longer changing under our feet, okay, but it also becomes easier to manage when we're talking about concurrency, and as we'll see later on, when you're talking about distribution, okay? So I got very interested with functional programming, and those ideas started to resonate really strong with me. But we have many functional programming languages, really. But there was one in particular that I like to say I fell in love with, which is Erlang. So for those who are not familiar with Erlang, Erlang is a programming language and also a runtime, a virtual machine. And it is really interesting because Erlang was created by Ericsson, which is a telecommunication company. And when you hear the story about the creators of Erlang and which problems they are trying to solve at the time when they designed the language and the runtime, they have a very interesting set of use cases in mind. For example, if you are Ericsson, you are a telecommunication company, and one of the things that you want to do is that you want to build a telephone switch. And what a telephone switch needs to do is to connect, for example, person A wants to talk to person B. So you get a connection to the telephone switch, and then the telephone switch connects to the other person, okay? And then you have the information coming and going. But if you are building a telephone switch, right, what you want to do is that you want to be able to handle as many connections at the same time, right? So if you have, hundreds of thousands of people talking, right, you want the switch to be able to handle that. So we already start to have an idea of concurrency, right, why they were worried about concurrency at the time. And then they have a very other interesting set of use cases. For example, sometimes you need to go in the middle of nowhere to install a telephone switch, like connecting two cities that are far away. And you don't want to, you don't want to go there every 2 months or every 3 months to give maintenance to the system. So they designed it in a way that it is robust. If something goes wrong with the switch, it should be able to heal itself, right, and go back up and running. Other use case that they had in mind is that everything needs to be distributed, because sometimes you want to call someone, but that person is talking to some other person from another switch. So the switches, they need to be able to exchange information, okay? So it's really interesting. They had all those use cases in mind, and then they designed a virtual machine to solve those problems. So that's what happened, and then they built Erlang, and Erlang was used for telecommunication for a good amount of time, and it was only in 2005, kind of 2006, where Erlang started to be used by web companies. And so, with the whole idea of web become more and more prevalent, people were starting to use Erlang, and that's because they realized that this use case I'm showing to you right now, it's very similar to the web, right? Instead of a switch, you have a server, and you want a server to receive connections from browsers, mobile devices, and you want the same server to handle as many connections at the same time. Especially now, right? Nowadays, we have mobile applications that are synchronizing data over the phone. So it's not more request response, right? It's like you have a connection open and information is coming and going all the time. And then you need to connect to internal endpoints. You need to connect to other machines. So they realized, well, if it was good for solving those telecommunication issues, it's going to be really good for the web. And a lot of companies started using it. So Amazon and Facebook, they are companies that use Erlang. We still have telecommunication companies like Ericsson and Motorola that use Erlang for telecommunication needs. And we have new companies like startups as Heroku. So if you ever deployed an application to Heroku, every time you need to access your application, it passes through an Erlang routing layer. Ryak is a database built by Basho that is written mostly in Erlang. So we have all those use cases, okay? And we have one that got really a lot of attention lately, which is WhatsApp. One of the reasons they got a lot of attention is because they were acquired by Facebook by 19 billions. And it's really interesting because they have given a lot of talks at Erlang conferences because they are almost all their system, all their backend is implemented in Erlang. So they gave talks and they wrote articles, and you can see in the articles that you're able to get 2 million connections on a single node. So for those who are not familiar with, WhatsApp is a messaging application you install on your phone, okay? And so you can send messages to your friends. So what this means is that you have 2 million devices, right, like mobile phones connected to a single machine. And then when someone sends a message, it broadcasts to the people that cares about it on that machine and throughout the whole cluster. And you can see if you go to this article in particular that I'm showing here, they're using a quite powerful machine. It's a machine with 24 cores, 96 gigabytes of RAM, okay? But even though they were using only 40% of CPU and memory. And this is exactly what we want, right? We want to write software that's a machine that has 2 cores or 4 cores. And then when we put it in production, and it's a machine with 24 cores, we want to use all of them as efficiently as possible. I like to say that it's 2016, so everything that we are doing in our computer, it should be using our cores. There's no excuse anymore, right? And it's not only the code that you write to run in production, but everything really. Are you loading code that should be using our cores? Are you compiling code? Are you doing something in your text editor? It should be using our cores in your machine. Otherwise, it's just a waste, right? It's wasting our time as developers, okay? And it's a very easy math to work out, right? So if you have 4 cores and your machine and whatever you're doing, for example, you're compiling code or you're running your tests, if it's using 1 core, it could, in the best scenario, be 4 times faster if it leveraged concurrency, right? So this is really important. It really matters, not only in terms of productivity, not only in terms of performance, but also in terms of productivity, okay? So cool, so, let's talk about Elixir then. We gave this background. I hope I convinced you how the Erlang virtual machine is this great piece of software. So, let's talk a little bit about Elixir. So we could say that Elixir is a functional programming language, okay? But I don't like to focus on that aspect, right? Because more than a functional programming language, Elixir really is a concurrent programming language. But even more than a concurrent programming language, Elixir is a distributed programming language. And that's the idea I want to build now for the second part of the talk, okay? So I want to take you exactly what it means to be distributed in Elixir case. And in order to do that, we need to learn about Elixir idioms. So let's get ready. This is the second part, okay? So the Elixir idioms. So here you can see I have this sphere here, this circle with sequential code. And I like to say that when we write code in Java, C, Python, Ruby, these are our code, right? We write sequential code and it's just a chunk of sequential code. And that's why, for those who have programmed with threads, that's why programming with threads is so hard, right? Because we have the same code and we need to think how the different threads are going to interleave and execute in that code, right? So, you know, this is typically our imperative programming languages, how they work. And Elixir actually is not really different, okay? In Elixir, we have sequential code, but the difference here is that the sequential code is into something very, very tiny called a process. And it's very important here from now on to the rest of the talk. Every time I say process, I do not mean an operating system process. I mean a very cheap, a very lightweight thread of execution inside the virtual machine, inside the runtime. We can create many of those, okay? And just to have an idea, in the WhatsApp case, didn't they say they had 2 million connections, 2 million clients connected? So they had at least 2 million processes running in that same machine, okay? So those are very cheap, very lightweight. We can create a bunch of them, right? So we create a bunch of those processes and they are all running at the same time. They are all running concurrently. And that's how we start to get the idea of concurrency, okay? So we have all those processes that is just sequential code that they are running. They're all doing things at the same time. And every time they actually need to work together or they need to exchange some information, they do that by sending messages to each other, okay? So, so now we have this idea, right? We have all those processes and they are concurrent, right? They're all running at the same time and they're also isolated. So when they need to talk to each other, they need to send explicitly a message. And in order to continue understanding, for us to understand deeper how those processes work, let's zoom in. Let's zoom in, okay? We have a red circle here. Let's suppose you're going to zoom in into those 4 processes and understand and look closer at what they're doing. And let's imagine that this particular application, okay, is a web application. So it needs to do many things, right? So if you have a web application, one of the things you need to do is, for example, to go talk to the database and get information out of the database. So you can imagine that we have a DB process, right, that is responsible for doing that for us. And then we have a web process, which is the one actually waiting for clients to connect and serve that requests. And then we can think that we have a statistic process that is calculating live information about the system, like how many users are connected and things like that. And we have also the mailer process, which is responsible for sending emails, okay? There's something very interesting here, because if I said that those processes, they are all running concurrently at the same time and they are isolated, it means that if something goes wrong, for example, if the mailer process crashes, it's not going to affect the other parts of our code, okay? And that's really important. And in order to understand why this is important, let's think what was going to happen if we're using another language, like Java or Python or Ruby. So imagine, for example, there is a web request and then you want to send an email in that web request. If there's something wrong by sending that email, it's going to generate, for example, an exception, right? And then exception is going to blow up that request and that request will fail. And if then if you don't have a mechanism in place, like if you don't use try catch or begin rescue, that exception can blow up the whole system, right? And when you think about it, it's really crazy, right? How can a failure in the mailer, in the thing that sends email, affect your whole application, bring your whole system down, okay? That would be equivalent, for example, of you, if you're running software on your machine, and then your browser can crash all the applications all the system that's running on your operating system, right? That doesn't make sense. But in the majority of languages, that's what happens, and we need to resort to mechanisms like try-catch to ensure that those things don't blow up. And if you think about it, it gets even weirder if we consider that exceptions is mostly a mechanism for us to signal that something exceptional happened. And when we are catching exceptions, it's basically our system is saying, hey, something went wrong, and then we just catch that and say, okay, thank you, now continue doing whatever it's doing, right? It's not, I like to say, it's not a healthy relationship, it's not a good habit to have, okay? So here, the way we have things is that we have those entities in Elixir, like the DB process, the web process, the stat process, the mailer process, and they are all isolated, right? They're all running at the same time. So what is going to happen is that if the mailer crashes, everything is going to continue just fine. And what we do instead is that if something goes wrong with the mailer, we are just going to start a new mailer because we have this process called a supervisor that its only responsibility is to look at the other processes that are running the system and act on them when something goes wrong, okay? And this is really, really important. And for example, why this matters, right? So we are using our computer. For example, today you're there working, you're using your computer, and then something starts to go wrong. Some application is not working, or there is something in the corner of your screen that is flickering, and then you're like, oh, something's not working correctly. What do? You go, you restart the machine, and the problem disappears, right? The problem is gone. And sometimes it never come back, right? You'll never see that problem again for the next 3 years you're using the computer, and it's gone. And the reason for that is because when we start our machine, we go back to the initial state, right? That is guaranteed to work. Is the one that we test when you're writing the software, is the one we test, is the one that the QA is going to check as well. So when we restart things, we go back to a working state, to a guaranteed working state. And when companies, they build computers, they really test that boot software, okay? Because that can certainly not fail. If that fails, everything is lost. So here's the same idea, right? Instead of catching exceptions, we even say the opposite. We say, hey, it's fine. If there is something wrong, let that exception bring that process down, because we have a supervisor that is going to look at that failure and act on it, okay? And then sometimes, so we start to have things like, so we have some processes that are doing some work, and then we have supervisors. And sometimes the supervisors have their own supervisors. And then we start to build something that looks like a supervision tree. Okay, so we have supervisors with some process with supervisors. So it's the whole tree. And when we have a tree, we package everything into an application. And that's how we ship our software. Okay, so cool. So if you're talking about idioms, we've learned a bunch of new words, right? We've learned about processes, which are very cheap, very lightweight thread of execution. We learned about supervisors, which are special processes that has the only job of supervising the other process and acting when something goes wrong. And then we package everything into applications, okay? And then we know that those processes, they are concurrent and isolated. So every time we need to exchange information, we need to do by message passing. And those words, right, those new words we added to our vocabulary, it's allowing us to write software with different properties, right? We have a concurrency because those processes, they are isolated and concurrent. We now are talking about fail fast, which means, again, if something goes wrong with the mailer, don't catch an exception, right? That's not healthy. What you want to do is like, okay, it's fine for something to go wrong. Let it fail because we have a supervisor, and the supervisor is going to act on it. And now you're talking about how to build fault-tolerant software, right? Because when things go wrong, and things will certainly go wrong, okay, your system knows how to react to those failures and go back to a working state. And there is one thing that we yet have to talk about that is in the title of the talk, is that with those abstractions, we can also build distributed systems, okay? So, but we haven't showed how, okay? So let's talk about this. Okay, let's go back to that screen where we have all those processes and we said they are running at the same time in exchanging messages. And the way this is implemented by the runtime is that it doesn't really matter if those processes, if they are in the same machine or different machines, sending messages between them is completely abstracted for you. So it's the same function call, the same API. You just say, hey, I want to send a message, and every process has an identifier. And it doesn't matter if that identifier is in the same node or it's on another node, okay? The code is the same. And that really leads us to write distributed software. I'm going to mention a couple of examples at the end of people using and doing interesting things with Elixir in production. And if we have time, I'm also going to do a live demo. We actually have time. So I have 2 live demos here, okay? I will pause for now to do one of them. And what I'm going to do is qualify the processes of fault tolerance, how we can think about the system. What I'm going to do here is that I'm going to start an application. So we have a web framework for Elixir called Phoenix, okay? And you know, it's a web framework. And here I have it running. So I have running on and I started the application and I'm going to call observer. I like to joke that one of the things that it's really good in these environments that the names, they are really obvious. So the supervisor supervises, the observer observes. And I'm going to zoom in. All that it can from the system. So it says, you know, how many CPUs I have. I've heard that I have a robot voice. Sorry, 1 second. Okay, so sorry about that. So we have this tool called the observer where it can get all the information we can about our system. So here we can see the amount of CPUs, for how long it's running, how many processes it has. So by just doing it, we have 148 processes because a lot of Elixir and a lot of Phoenix itself, it's all implemented with processes, right? That's the abstraction we have. How much memory we are using, so 30 megabytes after booting here. And then we have all those panes, okay? Information about how our system is being used, like load charts. In this case, because it's running my machine, there is no request happening. We can see how memory is being allocated and so on. And so the first one of them is the process pane, where it's going to list all processes that are running our system. What is cool about this is that, for example, this is a true story. If you go to the Phoenix website and you check the blog posts, you're able to reproduce the case with WhatsApp where they had 2 million connections on the same machine. But in order to do that, we had to optimize the code that we wrote. And the whole optimization process was like this. We started benchmarking, so we started to have like 40 different machines sending load to the server. And then we could see that things are starting to get slow. So we would come here to the process tab and we would say, hey, I will order those processes by message queue. I want to have the message queue. Since processes talk to each other by sending messages, they have a message queue. Those messages are stored. So if there's something slow in your system, it's very likely that it is one process that is the bottleneck. Everyone is sending it messages and it can't process them on time. So we would go here, we would order by message queue, we would say, hey, this is the slow process. We would optimize it and then we would receive 10 times more connections. And then we would find the other bottleneck and we would solve it. It was really straightforward. Okay, again, because of this whole idea of building everything with processes, and it really brings a lot of introspection to the system. We are also talking about applications, right, which is when you have supervisors with supervisor and with supervisors. So we have the supervision tree and we package that into an application. And when you run some code, you actually don't run a single application. You run many applications side by side. So when we are using Phoenix, so when you start an application, this web framework, okay, when you run your code, we have many applications. Here is an application too, okay? And the name of this application in particular is demo. For example, application says, hey, our application needs to talk to the database. So we can see it here. We call it a repository. And every time we talk in the database, and then this doesn't matter if it's Elixir or Java, one of the things that we usually do is that we have a pool of connections. So when your application starts, we start like 10 connections to the database. And every time we want to talk to the database, use one of those connections. And we can see all those here, right? So here we have repository. So here we have the repository, okay? Here we have a pool, and here we have all the connections to the database. And it allows us to do interesting things like, well, let's suppose that there's something wrong with the connection to the database. How is my software going to react to that? So in order to simulate that, one of the things I can do is that I can come to this process and say, hey, let me kill this process. Here's an idea of 231. Okay, so what I'm going to do is that I'm going to kill this process. And what I expect to happen in here is that this process is going to be dead, but because everything is supervisor, the supervisor is going to notice a failure and is going to start a new process with a new ID. So the ID 231 should be gone, okay? So let's kill this. And then the screen refreshed. It's gone and we got a new ID at the end, right? So because we are building in terms of supervisions, now it's really easy for us to reason about our software, how our software is going to react when things go wrong, right? When the database goes offline for a little bit, what is going to happen? We can come here, we can click those processes, we can understand, right? And try to emulate them and try to get an idea of how our application is really going to work in production. In demo, I'll go back to the application, to the let's do a small pause here. So what we've talked about so far, so we first talked about the Erlang virtual machine, and then we came and started to explore all the idioms that we have with Elixir and how we allow us to write software differently. And we just saw a demo that explored a little bit in a more visual form those concepts, okay? Cool. But the thing is, everything I said so far about those idioms, they not only apply to Elixir, they apply to all the languages that run on this Erlang virtual machine. So for example, in Java, we have the Java virtual machine, and we have many languages running there. We have Java, we have Scala, we have Clojure, and so on and so on. And Erlang is the same. We have the Erlang virtual machine, we have languages like Erlang, Elixir, and NLFE, and everything I said before apply to all those languages because those foundations, they come from the virtual machine. They come from the runtime, okay? So that said, we're probably wondering, okay, so why should I choose Elixir? What Elixir tries to bring on top of everything else, okay? So, and that's the final part of the talk. So what we're going to talk about, I want to talk about three things that we have for Elixir. So and I want to talk the language goals, okay? We have three goals for the language. The first one is compatibility. The second one is extensibility. And the third one is productivity, okay? And we're going to look at them one by one. Compatibility, it's easy, right? Because it basically means that everything I have said so far, all those properties, okay, that we have on the runtime, we are going to be able to leverage them from Elixir, okay? So everything I said, it's going to work just fine for Elixir. You're going to be able to explore and rely on all the tools that we have for the runtime. And that's what we saw with Observer, for example. It's a tool that comes with the runtime. It's not a tool built in Elixir, and we can just use it just as fine, okay? So that's one, and that's easy. We can move to the second. The second one is extensibility. And there are many ways to define extensibility and to consider the language extensibility in terms of features. And I want to talk about one in particular. And to do that, I want to use this quote from Guy Steele. He gave a talk called Growing a Language. It's one of my favorite talks of all times. And he said, at the end of the talk, he said this. Now we need to go meta. We should now think of a language design as being a pattern for language designs, a tool for making more tools of the same kind. And what this means is that today our programming field is so wide that it is impossible for us to write a programming language or to design a programming language that is going to work across all of those domains efficiently. So the language needs to be extensible, okay? Otherwise it's going to be very restricted. And that's one of the goals that we have for Elixir, is the ability that you can get the language and extend to the domain we're working on. And we have many features to do that. One in particular is called macros. So here's an example. I think this is the first time we see some Elixir code in the talk. So here I'm defining a module. Elixir code usually is always defined inside modules. And on the second line, I'm saying use XUnit case. Okay, and that's bringing, so XUnit is our test framework, and that's bringing the test framework capabilities. And then we define a test. We say, you know, I want to test that, like if I'm testing the basic math functions, I want to test that 1 + 1 = 2. And what is really nice about XUnit is that, so depending on the programming language you use today, you would never write a code like this. You would never write assert 1 + 1 = 2, because your test framework would give a very poor error report. It would say, well, if something goes wrong, it would say, you expected false, but it got true, or something like that, or expected true, but it got false. So you need to use things like assert equal, assert match, assert different, and things like that. In Elixir, we only have assert, and that's all we need, because assert is a macro. And as a macro, it can look at the code and infer properties from that code. So for example, if something goes wrong, those are the reports you get with Elixir. You only use assert, but it knows exactly what you're trying to do. It knows you're trying to compare this value with some other value, and it knows exactly where that was, and then you can get all this information, right, without needing explicit input from the developer. We can just look at the code and assert those properties, okay? Here's another example of, so that was an example of we getting Elixir and extending to the testing domain. Here's an example of we have a language integrated query called Acto, and these are just using Elixir, okay? Actually, it's not a language integrated query, it's just some regular Elixir library, but it's inspired a lot from Link from .NET. And so this is just a regular Elixir library. There is no language extension in particular. And what we are doing here is that we are writing a query that we are going to send to a database later on. It can be a Postgres database, it can be MySQL, it can be SQL Server, and we are writing it just using Elixir. Okay, there is no special syntax nor anything, it's just Elixir. And it's really powerful because we can provide features like security. What we do is that we compile most of the query at compile time, so we are not doing work at runtime as well. And it's all based on this idea that we can get Elixir and bring it to the domain we are working on. And then we have many other examples of extensibility. So for example, if you're interested in web frameworks, you can check Phoenix. You're going to see some examples in there, and so on. And in order to explore the last goal, I want to talk about productivity, okay? And productivity is kind of tricky, right? Because how can you say that a language is really more productive than the other one, okay? It's hard to measure, you know, in a good way that's not biased and so on. So when we talk about productivity, we are talking about tooling and the developer experience. So for example, things that we have in Elixir that's going to really help you be productive is first-class documentation. Documentation should be easy to write and it should be easy to read, right? If it's not easy for you to do those two things, it's not very useful. You're not going to be productive. If you need to be chasing how some function works, or even trying to find the code you want to do, it's hard, right? Finding examples. I have a second demo really soon, and we will explore a little bit of this, okay? It's also having a very good tooling, so shipping with a test framework, shipping with IEX, which is, we saw it briefly when I started Observer, is a tool where we can type code. Shipping with Mix, we're going to explore it really, really soon. And also the idea behind Hex packages, which is, so in Elixir we have a package manager called Hex, and if someone solved the problem, it should be easy to bring that solution into your system, right? So we can rely on it. and Hex basically allows us to do that. So I'm going to do a very quick I've heard that if I'm doing many things with my computer, with the screen, the quality of my voice may reduce a little bit. So I'm just going to be really brief about this, okay? So here you can see that I started something called IX, which is interactive Elixir. And here I can run any Elixir code. Okay, so 1 plus 2, I started Observer before, and so on. And then, for example, I said about documentation, okay? So one of the very nice things that we have in Elixir is that it's very easy for us to access documentation. So for example, imagine that we want to work with strings. So what I can do here is that I can just say H for help and type the name of the module string, and it's going to the module here. And also to this connector and that's information and so on. We also have a fantastic website for documentation, so see everything it has to say about strings, and it contains examples. And what is really nice is that all the examples that you have in the documentation, so you can the documentation is always up to date, right? This is really useful. And okay, so these modules I want. And what if I want to see all the functions that I have in the string module? I just type the dot, everything that I have there, so I can say, oh, okay, I want to see the case. Let me see examples. Then you can just go and explore the documentation. Okay, so here it's also the second. So we can hear you refer to the web interface and search for the case in particular. We're going to flow. So this is example documentation. Another regarding is that it ships with this tool called Mix. And with Mix, you can do everything from starting a new application. So I can say Mix new hello. And I just have a very simple project with everything I need to get started. And Mix knows how to compile the code, for example. Code, Mix tests, and so on. Okay. And I'm going to extend a lot further into the demo. So I'm going to go finish the talk and all. Okay. So can follow and elixir-lang.org. We have a very good getting started guide that's really going to help you. You can put your feet into the pool and see if the warm is water, if you're interested in it. And then if you want to go deeper, there is a learning section where we have plenty of resources. There's really a lot of resources from books, screencasts, other websites that is teaching Elixir in different languages, and so on and so on. So you can check, for example, some of the books, okay, that we have for Elixir today, and check the website for more of them. And finally, I want to thank my company, Platform Attack, that is investing on Elixir for all this time. It has been 4.5 years, and we are making great progress in really extending it to other domains. Okay, so that's it. I want to thank everyone, and now I'll go for questions. Okay, so I'll put the control panel up, and let's see if we have questions. No, I don't want to check. Okay. We have 3 questions. All right, so, okay, one is an observation. Okay, so let's talk, since we have time, let's talk about observation. So the OTP is not really part of the Elixir language, but Erlang can only be effectively used with it. Okay, that's a very good point. So I did not go a lot into details, but as soon as you start learning about Elixir or Erlang, you're going to hear about OTP. And OTP means Open Telecom Platform, but it's a really old name when you think about OTP. One way to think about it is just to think about it as the Erlang standard library. So, for example, the observer tool I use, it's an OTP, and I just consider it to be part of the Erlang standard library. Okay, this is a simplification, but it's enough. So the other one is what you'd not use Elixir for. This is also a very good question. So one of the things that, if you ask this question, the answer that is going to come to you is, for example, if you are building tiny command line apps that you want to distribute to other people, I wouldn't necessarily use Erlang or Elixir because it needs a virtual machine. So for shipping with that code, you need to ship the whole virtual machine, and then you need to boot the virtual machine. And then if you use something like that can build very tiny executables that you can just distribute it, that's going to be much more easier for the user installing it and so on. But depending on what you're doing, and shipping a VM with 15, 20 megabytes is not a problem, then just go ahead and use it. Another example where I would not use Elixir is, for example, if you need to do very heavy number crunching. So today, if you need to do very heavy number crunching, you'd probably delegate those parts to do it in C and so on. But again, on the other hand, right, a lot of people say, hey, what would not do in Elixir? But it depends a lot on from which language and which perspective you're coming from. Because, for example, if you're doing number crunchy heavy things, but you're doing it in a language where you cannot leverage concurrency, so even Elixir not being super efficient at number crunching, the fact you can write the software concurrently and with the properties I talked about, it's going to be a productive experience altogether. Okay. So I have a question from Jeff. With regards to distributing Elixir applications, how do you approach maintaining shared state between the nodes when it can't be avoided? Okay, so this is a very good question, and it's a very complex answer. Okay, but what is important to say here, from the perspective of the language, is that we just say how we give you the communication. We know how you can reach the other node in some other machine and how they can exchange messages, and it gives you the abstractions, but it does not bring you the tooling, for example, of how you're going to maintain shared state between those. So for example, we have so one of the solutions that you could do is that you could use the RIAC database, right, which is implemented in Erlang, and then you can just interface with it directly, and if you want to keep shared state, you can write to some RIAC nodes, or even leverage the RIAC foundation. So, or if you want, you can just put it into a separate database that it's going to be centralized. It can be a potential single point of failure, but if that works fine for you, that's fine. So in other words, the answer here is we don't really do much in this case. Like, it's up to you to build the solution. It mostly provides the pattern, right? It provides the process, it provides the message passing. So building the final solution is really straightforward, but when it comes to how to maintain the data, and I'm going to synchronize that between nodes and so on, it's going to change a lot. One last example related to this question, because it was a really good question, is, so I talked about Phoenix, and one of the features that is coming with Phoenix 1.2 is the idea of presence. So for example, imagine that you're building a chat application, and then you have different users in different rooms, right? The same user can be in 3 or 4 rooms. Sometimes the same user can be in his computer and his phone, with his phone device, in different rooms, okay? So, so how do you solve that problem? And the way that Phoenix solves it is by using something called Phoenix Presence that is based with CRDTs, that is completely decentralized. There is no single point of failure. It doesn't need external dependencies. The nodes, they are just talking to each other and exchanging this information, okay? And when you look at the implementation is really small, right? Because, again, the patterns that enable this kind of solution, they are all there, okay? Thank you, Jeff. Great question. I would like to say a little more of the functional part in Elixir. I won't have time to go into detail right now, and I've heard that when I'm doing a lot of things in the screen, my voice is not so good. So to learn a little bit more, you can send me a question later. Or one of the things that I forgot to talk about is that if you go to the website, here on the right panel, we have a section called Join the Community. And then we have links to, if you like to use Slack, IRC, mailing list, issues tracker, the forum. And so if you have questions, you can send them to me, or you can reach those links and learn more about it there and just talk and get involved in the community in general. But the getting started is going to cover some of the functional paradigm and why we have that in Elixir. Okay, sorry that I cannot go deeper right now. I'm going to go back to the last one, Ben. Some question, and what big companies are using Elixir in production? So this is another very good question. We, from Platform Attack, which is the company behind Elixir, we released, I think at this point, more than 1 year ago, a series called Companies Using Elixir in Production. So you can Google that and you can see some examples, very interesting cases, both from video processing companies to regular startups doing things on the web and so on. Something else that you can do is to go to the Phoenix Framework webpage. We have some companies that are using Phoenix in particular. So they're going to find companies like Bleacher Report. And Bleacher Report, I think they're the second biggest sports media company in the United States. And they are using Elixir and Phoenix in other parts of their infrastructure. Another company that is using Elixir, and they wrote about it, and you can search, and this is not Phoenix, just Elixir itself, is Pinterest. So you can search about that and learn a little bit more. There is also moz.com. You can search also Elixir and moz.com. They have a very interesting use case where they're building their analytics in their system. Before, it was heavily dependent on the database. So they had to go to the database and get information from the database quite frequently, and that was not as fast as it could be. And they started to build a new version with Elixir, and because of this whole idea with processes, we start to think more about long-running processes, right? And thinking more about sessions and how user can interact with the backend over a long period of time. So what they did there is that they ditched the database, and what they do is that when you're playing with the analytics, they bring the data from somewhere and keep it in memory. So as you're using the website, as you're using analytics, everything is in memory, and then you can process and give feedback to the user much faster. So I think it's a very good example of using some of the idioms that we have learned here to simply write software in a different way. Okay. And the last question, I think, which is, does Jenkins support building and testing Elixir apps? I'm almost sure it does, because I think that at this point, someone probably is doing that. So I'm going to give the same advice. Go to Elixir forum or to the mailing list and ask, hey, does someone have a Jenkins recipe? And if they can share, if it's not available yet. But I would expect it to be. So in general, Elixir is in a good point in the adoption curve where text editors, they already have packages that give you a good experience when using text editors. Different operating systems has an easy way to get started with Elixir. So doesn't matter if you're on Mac, on Linux, or Windows, you have a lot of different ways to get it on your machine, so you can get started fast and so on. So I would expect to have something for Jenkins, and please ask around and let us know. Okay, so I want to thank everyone for coming here and for sending the questions. Great questions, and that's it. If you have anything, if you'd like to learn anything more, just get in touch. We would really like to hear more from you. Thank you very much.